Okay, the next section we're going to talk about is Chapter 1, Section 6, Absolute Values. Most of you should be familiar with the concept of an absolute value, but I'm just going to review it. Absolute value measures distance. The distance a number is away from zero on the number line. And the way we notice when we're using absolute value is we use these straight lines. For example, measuring distance, what's the distance of positive 8 from 0 on the number line? It's 8 units away. What's the distance of negative 8? Well, if you think about it, if I were to draw a number line, and this is 0, and this is positive 8, and this is negative 8, if I measure distance, this is just going to be 8 units, and this is going to be 8 units. So we just say 8, okay? When you use it in an expression, you simplify it, you use it sort of like parentheses. The only thing that you can't do is you cannot distribute into absolute values. Don't forget that you cannot distribute into absolute values. So for this, 8 minus 2 is 6, minus negative 14 plus 9 is going to give me negative 5. And then I calculate the absolute value. What's the absolute value? The distance of 6 from 0, it's 6. What's the distance of negative 5 from 0 is 5, so my answer is 1. So solving absolute value equations. When calculating absolute value equations, you always have two cases, because if you think about it, the answer, the distance is always, you have two answers. 8 can either be positive 8 or negative 8, because there's two distances that equal 8. Okay, extraneous solutions are solutions that algebraically come out correctly, but when you plug and chug the answer to check your answer, the solution is false. And this happens every once in a while, so we have to make sure and check these when we're done completing the problem. For example, one thing that you have to always recognize is, when is this true? When can you measure distance and get a negative answer? Never. You can never measure distance and get a negative answer. So if you ever have this type of answer, the answer is no solution, okay? It doesn't matter. If you plug in 3 for x, you're going to get positive 3. If you plug in negative 3 for x, you're going to get positive 3. You cannot get a negative answer. Let's move on. We'll talk about extraneous solutions more in a little bit. So solving an absolute value equation. Basically what I have to know is that everything on this inside, if I can equal case 1, if I can have 2x minus 1 equal 5, if that 2x minus 1 equals 5, this equation would be true. However, case 2, if 2x minus 1 equals negative 5, if I could plug in negative 5 in there and then measure the distance, it would also be true. So I have 2x minus 1 equals negative 5. Now let's just solve both equations. Add 1. So I have 2x equals 6, divide by 2, x equals 3. So there's my first answer. Solve the next equation, plus 1. So I have 2x equals negative 4, divide by 2, x equals negative 2. Before I move on, I have to check for an extraneous solution. We did the math, everything looks correct. Now we have to check for an extraneous solution. And that's what we're going to do next. So on the next page I have a check. Let's check and make sure net 3 works in the original equation. A common mistake students make is they actually plug 3 into this equation. That's not what I want. I want to plug 3 into the original equation. So the absolute value of 2 times positive 3 minus 1 equals 5. 6 minus 1, the absolute value of 5 is 5, so that checks out. X equals 3 is one solution to that equation. Now let's check negative 2. So I have the absolute value of 2 times negative 2 minus 1 equals 5. Absolute value of negative 4 minus 1 equals 5. What is negative 4 minus 1? It's negative 5. However, when you measure the distance of negative 5 from 0, we're going to get positive 5. So we have 5 equals 5. That checks out. So absolute value equation has two solutions. If I were doing this in Math Excel, I would put in both solutions. Both of them work in that equation because we have a positive and a negative. Let's do another one. Now this one's a little bit different. Pay attention here. Before I solve this one, you have to notice that I have something on the outside of the absolute values. When you have something on the outside of the absolute values, you have to get rid of it first. So I'm going to add 1 to both sides. I'm going to solve for the absolute value. So I have 3 times the absolute value of x plus 2 equals 9. And then divide by 3. So now I have the absolute value of x plus 2 equals 3. Now that we have the absolute value all by itself, now we can go ahead and we can do our case 1, case 2, because that's how you solve an absolute value, is you have whatever's on the inside. If I can get whatever's on the inside of the absolute value is equal to 3 or negative 3, it would be true. So case 1, x plus 2 equals 3. Case 2, x plus 2 equals negative 3. If I can get that inside to equal 3 or negative 3, this equation will work. So subtract 2, x equals 1, subtract 2, x equals negative 5. Now that I have my 2 solutions, let's check them to make sure that they work. So I'm going to take 1 and plug it into the original equation. So I have 3 times the absolute value of 1 plus 2 minus 1 equals 8. So I'm going to 3 times the absolute value of 3 minus 1. 3 times the absolute value of 3 is 3 minus 1. So I have 9 minus 1, and it's 8. And that checks out. We're good to go there. Let's check negative 5. So I have 3 times the absolute value of negative 5 plus 2 minus 1. And I want that to equal 8. I'm running out of room. So I have 3 times the absolute value of negative 3 minus 1. Well, what is the absolute value of negative 3? What's the distance of negative 3 from 0? It is 3. So I have 3 times 3 minus 1, which is 8. So that one checks out as well. So that one has 2 solutions. All right, let's move on. Let's try another one. This one, my absolute value is already by itself. This time it's not just a number, we have it equal to an entire expression. So we have to still do case 1, case 2, but it looks a little different this time. So case 1, I have 2z minus 3 equals 4z minus 1. In case 2, and here's where it looks a little funny, 2z minus 3 equals negative, and then the entire thing. I have to make this entire thing negative. I have 4z minus 1. Those are z's, not 2's. And 2's and z's tend to look the same, so I put lines through them. Now, let's solve. I want to get my z's on the same side, so I'm going to subtract 2z from both sides. So I have negative 3 equals 2z minus 1. Add 1. So I have negative 2 equals 2z. Divide by 2. Try to make my 2's look like 2's instead of z's. So it's negative 1 equals z. That's my first answer. My second one, I'm going to distribute that negative first. So I have 2z minus 3 equals negative 4z plus 1. Change the signs. So I'm going to add 4z to both sides. So I'm left with 6z minus 3 equals 1. Add 3. So I have 6z equals 4. Divide by 6. Z equals, I'm going to simplify that, 4/6 to 2/3. I'm going to leave it as a fraction, which is fine to have. So now to do my checks, I'm going to take negative 1 and plug it back into the original equation. So I have the absolute value of 2 times negative 1 minus 3 equals 4 times negative 1 minus 1. So I have the absolute value of negative 2 minus 3 equals negative 4 minus 1. Absolute value of negative 5 equals negative 5. However, what is the absolute value? What's the distance of negative 5 from 0? 5. Does 5 equal negative 5? No. So this is an extraneous solution. That is not going to work. Okay? 5 does not equal negative 5, so we would say that's an extraneous solution. And we talked about that on the second page of the notes. So now let's plug in 2/3 and make sure that one works. I'm going to go ahead and plug it in down below so that I don't run out of room. Okay, so I'm going to plug in 2/3. So I have the absolute value 2 times 2/3. And if you need to use a calculator, you can. If you don't like fractions. Nope, not Z. 2/3. So this is 4/3 minus 9/3. Okay, how did I do that? 2 times 2 is 4 over 3 minus, what's 9 divided by 3? 3, and why did I do that? So that I had a common denominator. So this gives me negative 5/3. 4 minus 9 is negative 5. My thirds is my common. Equals 4 times 2/3. 4 times 2 is 8 over 3 minus 3 over 3 because I want a common denominator. 8/3 minus 3/3. 8 minus 3 is 5. Is 5/3. What's the distance of negative 5/3 from 0? Positive 5/3. So 5/3 equals 5/3. That is the only solution. So if I were putting it into Math Excel, that number right here is the only one that I would put in. Okay? And on your worksheet, you would only have one. Go ahead and do 1-6 worksheet 1.